In mathematics, it's fairly common for us to want to describe sets of numbers, for example, the set of all inputs in a function or the set of all outputs that come out of a function. And last class we talked about 4 ways that are commonly used to do this. Verbally is something that we are all familiar with, and that would be to just describe the set in words, such as all numbers greater than or equal to 3, less than 8. We talked about how we can use interval notation when we want to include or exclude endpoints. We talked about using the roster method, using inequalities to express these sets and to visually represent these using the graphical representation. And it's important for us to be able to work with all of these different ways because the person you're communicating with might prefer a different method than you, and we still want to be able to communicate clearly the same sets of numbers. And so one thing that I would like to point out at this point is notice that we have a difference here, and that is when we want to include the endpoint 3, so this would be the left endpoint, this is included in this set. And when we want to include an endpoint, if it's on the left, we use a closed bracket. If it's on the right, we use a right closed bracket, and we call these closed brackets. If we're using a graph, then we would use a closed point. And we see that over here we have a closed bracket, we have a closed dot, and here we used an inequality that includes 3. And on the other hand, when we have the right endpoint, 8, this is excluded. And so when we exclude endpoints, we use open parentheses if we're using interval notation, and we use an open point if we're doing this graphically. And we see that being used with the open right parenthesis with the 8. When we're using interval notation, we have the open point plotted at 8 on the number line, and over here we have the strict inequality. All right, and one last thing I want to mention before we take a look at some other examples, and that is how do we deal with infinities, with these different representations. In other words, if I want to write out the set of numbers x, all values of x that are less than or equal to 4, so my right endpoint is 4, and I want to include that, so I use the closed bracket over here, and right, in theory I don't want to have any closed or any lower endpoint here to cut off my interval, so I go all the way off to negative infinity. And with infinities, either positive or negative, we always use open parentheses since we exclude negative infinity from this interval. We never can reach. So we don't include it. And we do the same with positive infinity. For example, if I had x is bigger than 0, here I would go 0 up to infinity. We exclude the infinity in this case too. Now let's take a look at a couple of examples. Okay, in this example, we have a number line, a graph of a set of values of x. And so on the left, what's indicated in red, we have all values of x that are less than minus 2. strictly less than minus 2. We have an open dot there. And on the right, in blue, we have all values of x that are greater than positive 2. And we would want to include any value of x that falls either in this set or in that set. So in other words, we can say these are all values of x that are less than minus 2 or all values of x that are greater than 2. And so the way that we write this out mathematically, well, the set in red, we would say this is everything less than minus 2. So I'm going to exclude minus 2 on the right, go all the way out to minus infinity, and remember we use open parentheses for infinities. For the set in blue, I would say 2 up to infinity, and I connect these two sets with a union symbol. So this is what we'd call a union of two sets, and for a union, we use the U. Okay, so this means either the values fall in the red interval or in the blue interval. Okay, one more example. Let's say here we have the set of all values of x, where x is less than 0, and the values of x that are greater than or equal to minus 4. Okay, and we want to write this set in interval notation. We don't have to do this, but maybe let's first get a picture of this using a number line. So all values of x that are less than 0, here's 0. I would put an open dot, go all the way off to the left. So that's in red. All values of x that are bigger than or equal to minus 4, here's minus 4. I have a closed dot, and I go up here. And now we want to make sure that we include only values of x that satisfy both of these conditions. So that would be this set right in the middle. And so we could write this out in interval notation, on the one hand saying, well, this set in red, this goes from minus infinity to 0. This set in blue, this goes from minus 4, and we include that endpoint. So we put a closed bracket there up to infinity. And again, we have these open parentheses with infinities. And I'm not going to use the same union symbol because we have a different connector here. We need the values of x that are in both of these sets. So for and, we use what's called the intersection symbol. Okay, and this would be a totally fine way of expressing this in interval notation, but we can see from the picture that this overlap is the same thing as saying all values that go from minus 4, including minus 4, and going up to but excluding the endpoint 0 on the right. So we put an open parenthesis on the right. And now we've taken this intersection of two sets and written it nicely in interval notation as a single set, which is probably preferable than writing it as two separate sets intersection. So to just recap what we've talked about in these two examples, when we have an or, like in the first case, we use the union symbol, and that's the U to denote a union of two sets. And in the second example, when we talk about the intersection of two sets, so all values that fall in both one and in a second set, we use the intersection symbol.